All right, more circle stuff. We've dealt with angles, central angles, and inscribed angles, and those will make a comeback. Don't worry about that. But right now, we're going to look at some things with line segments and lines that interact with circles. So we got some vocab here. The first vocab word we have is chord. A chord is a line segment whose endpoints are both on a circle. So on the picture here, you see this dark blue line segment. That is a chord. Both of its endpoints are on the outside of the circle. So one chord that you often work with is the diameter. The diameter of a circle is technically a chord because its endpoints are both on the circle. But a chord doesn't have to be the diameter. It can be any line segment that goes from one point on the circle to another point on the circle. A secant is basically a chord that keeps going. So a secant, it says it's a line that intersects a circle at 2 points. So in the picture here, you have this green line. It hits the circle here and then down here, but then it keeps going in both directions. And a lot of times you'll see that with the secant. Sometimes with the secant, it won't be a line. It'll be like a ray, or it'll just be a longer line segment. So sometimes you'll see a secant that just does something like this and ends at a point outside the circle and intersects with something else out there. So a secant is just any line or segment or ray that intersects the circle at 2 points. All right, and then we have a tangent. And what can be confusing with this word is that we've already talked about tangent when we did trigonometry. And in trigonometry, tangent is when you have a right triangle. It's the ratio of the opposite side to the adjacent side. With circles, we have a different meaning of the word tangent. Here, it's a line or a line segment that touches one point on a circle but does not cross into the circle. And you can see an example of that here on the picture. This red line is a tangent. And so when you have a tangent, it just basically grazes the circle. It just comes right by, hits it at one point, and keeps going. It doesn't actually cross over the circle or into the circle. One property that these tangent lines have is at whatever point they graze the circle, so this green point here that I've already made, they will be perpendicular to the radius or the diameter at that point. So if you see here, we've got a diameter. I'll draw a radius here in green. When it hits the tangent line at this point, it makes a right angle. And that will always be the case for any tangent line. At the point it hits, it will make a right angle with the radius. The word tangent to describe this line and the word tangent that we use in trigonometry both come from the same place. They have a common root, and that might be something we can go over later that you might learn later on. They are related, but for what we're doing, they're really talking about different things. So just keep that in mind. We're talking about a different type of tangent in this situation than we were a couple weeks ago. All right, so these new vocabulary terms, chord, secant, tangent, are going to introduce us to some new formulas that we're going to use to find the relationships between different lines and line segments that interact with the circle. And the first one we've got is the intersecting chords theorem. And you can see that right here. We have two chords inside the circle that intersect each other. And what I want to do to make clear what this little formula is talking about is I'm going to label my line segments. So I'm going to, this little part from A to E, I'm going to call this W. The little point from E to C, I will call X. B to E, the pink part, we'll call Y. And then the red part from E to D, we'll call Z. So we have four parts, W, X, Y, and Z. And what this formula here is telling us is that W times X is equal to Y times Z. So if you have two chords that intersect and they cut each other into two parts, then when you multiply the two parts of the one chord, it will be equal to what happens when you multiply the two parts of the other chord. So let's look at a couple examples of this and see how it works and how you can use it. So here, I might just draw some arrows to make it really clear what everything's pointing to. X is this little part up here. The 5 is the little part of the other chord here. 9 is referring to this piece right here, and I think 15 is pretty obvious what it's referring to. So using this rule, what we can say is X and 15, these are two parts of the same chord, X and 15. So I can take X times 15, and then I've got the 5 and the 9. Those are the two parts of the other chord. So I have 5 times 9. And I can say that these two things are equal. X times 15 is equal to 5 times 9. So let's work this out. X times 15 is 15x. 5 times 9 is 45. 15x is equal to 45. So all we need to do here is divide by 15. And we know that x is equal to 45 divided by 15, which is 3. So that's what it asks us to do, is to solve for x, and that's how we would do it. By setting up these two expressions, by multiplying the two parts of the chords, and then making them equal to each other. This one gets a little more complicated. You see we have two x's involved now, and they're part of bigger expressions. We have like x minus 9, x minus 5, but it's going to work out the same way. So let's start with x minus 5. That is a part of the same chord as the 21. So we're going to take x minus 5, multiply it by 21. When you have expressions with two terms like this, I would write it this way, with the 21 on the outside, so you have 21 times x minus 5 like that. Then we're going to do the same thing with the other chord. We have an x minus 9. We're going to multiply it by 24. I'm going to write it the same way. All right. So now the next thing I want to do is distribute. So I'm going to multiply the 21 by both of these things. I get 21x minus 105 equals, and I'm going to do the same thing on the right side with the 24. I'm going to distribute it. I will have 24x minus 24 times 9 is 216. And now this, going back to algebra, is when you have an equation with a variable on both sides, and the key here is to get all the x's on one side together and all your numbers on the other side together. So there are different ways to approach this. What I like to do is take the smaller number and subtract it. So I'm going to subtract 21x from 24x, because that's going to give me a positive number for my x. And on the left side, I'm left with a negative 105. On the right side, I have this minus 216. One thing, when you cancel out your x term, if the next thing is being subtracted, once that x is gone, it still has to have that negative sign in front of it. So be very careful with that. Now I want to get x by itself, so I'm going to add this 216. And when I put those together, I end up with 100. So you have negative 105 and positive 216. That's going to give me 111 equals 3x. And then my final step here is to divide this by 3. And when I do that, you take 111 and divide it by 3, you should get 37. So x is equal to 37. So it's a good review of algebra stuff, which, we haven't done that much of in this class, and that's going to be important for whatever class you take next year. All right, the next rule we're going to talk about is the secant-secant theorem. And so here we have two secants, and these secants are line segments, and they both cross through the circle and then meet at a point on the outside of the circle. And again, we've got basically 4 parts, 4 line segments that we're going to look at. And again, I'm gonna label them W, X, Y, and Z. All right, and I would really encourage you to jot this part down, because the way I'm going to show it to you is going to look a little different than what they have here, even though it's really the same thing. So what they have here is they say pH times PG. So pH is the W from P to H. So we got W. Here's the thing you have to be really careful about. PG, we're going from P all the way down to G. And that is not just W, it's not just X, it's W and X together. So we have to do W plus X equals. Then same thing with the other secant. We have PE, that's just Y. But then we do PF, that's from P all the way down here. So that's both parts, it's the Y and the Z. So it's going to be Y times the Y and the Z. So what you end up doing is you take the part that's on the outside and you multiply it by both parts of the secant added together. You do that with both secants and then you set them equal to each other. So we have W times W plus X is equal to Y times Y plus Z. So again, we're going to see a couple examples of this to see how this will work. So here, we've got 2 secants. The top one here, we have an 8 and an X. So I'm going to take the 8, that's the part on the outside, and I'm going to multiply it by both parts added together. So 8 plus X. And then on the other side of the equal sign, I'm going to do the same thing with the 6 and the 18. The 6 is the part on the outside of the circle, so it's going to be out here in front of the parentheses. Then inside the parentheses, it's going to be the 6 and the 18 together, 6 plus 18. So to work this out, on the left, I'm going to distribute my 8. I'm going to multiply it by both terms here. 8 times 8 is 64. 8 times x is 8x. Over here, what I want to do, I could distribute the 6, but it's going to just be easier, I think, to add together the 6 and the 18, which is going to give me 24. And so I'm just going to go ahead and take 6 times 24 over here, and that gets me 144. So now I just have a 2-step equation I can solve. I can subtract the 64 from both sides. We have 8x equals 144 minus 64 will give me 80. And I can divide by 8. And x is equal to 10. So that is the secant theorem in action. We're going to do one more with a slightly more difficult example here. Hopefully you can see this okay. This time, one thing you have to be really careful about, on all the examples we've looked at so far, it's told us to solve for x. Here it says to find NL. We want to find the measure of NL, which is a line segment from here to here. So we got to keep that in mind. And so after we work this out and figure out what x is, we're going to have a little bit more work to be able to answer this question. The first thing I want to do is set up an equation. So I'm going to look first at this secant here on top. My outside part is a 4. And then I multiply that by both things added together, both parts added together. So I have a 4, again, plus x minus 8. Then I'm going to do the same thing with the other secant. I've got a 3 on the outside, and then in the parentheses, I will take that 3 and add it to the other part, which is x minus 5. So I think before I distribute, I'm going to combine my like terms inside these parentheses. Here I have a 4 and a minus 8, a negative 8. So that will turn into a negative 4 when I put those together. So I'm adding this 4 onto this minus 8, and it's going to give me a minus 4. I'm going to do the same thing in this other parentheses. I'm going to add the 3 onto the negative 5 or the minus 5, and that's going to make it a minus 2. So I just combined my like terms in there. Now I'll distribute on both sides this time. I'm going to get 4x minus 4 times 4 is 16. I'll have 3x. 3 times 2 is 6, so minus 6. Once again, we have a variable on both sides. I like to take the smaller term with a variable and subtract it so I don't get any negatives with my variable. So I'm going to subtract 3x. That gives me 1x, or just plain old x. We have minus 16. And then over here, don't forget to keep that negative in front of the 6. Now all I need to do is add 16 to get rid of it. And I get x is equal to positive 10. And I probably didn't need to say positive 10, but this is a good point to mention this. When you are dealing with these types of problems and you're finding the lengths of line segments, your lengths should always be positive numbers. Now, here's the thing, like the line segment is not x, it's x minus 5 or x minus 8. So whatever you get for x, when you plug it in, you need to get a positive number after you plug it in. So speaking of plugging in, we've got a little more work to do here because we're not just finding x, we're finding NL. So NL, this line segment that we've already looked at here, is made up of 2 parts. We have the 4 and we have the x minus 8. And now that we know what x is, that it's 10, we can figure out that x minus 8 would be 10 minus 8, which would be equal to 2. So the idea with NL is that the part outside of the circle is 4. The part that's inside the circle is 2. And if we put those together, the total length of NL is going to be 6. So our final answer here, the length of NL is 6. One more rule. And the nice thing about this rule is very closely related to the one we just looked at, the secant-secant theorem. So this is tangent-secant theorem. And so if you look at this diagram on the bottom from E to D, that's a secant just like what we were just doing. The thing that's different here is the line on top, the line segment on top, doesn't cross through the circle. It's a tangent. It hits the circle at one point. So again, I'm going to label these. I'm going to label the blue part, the tangent part, x, and then the other secant part, I'm going to divide into y and z. And so here, if you look at what they've got, they have EA times EA. And EA is the blue part. It's the tangent part. And so that's going to be x times itself. And then we have EC times ED. So EC is the pink segment, that's y. But again, just like what we just did, the other part, ED, goes from here all the way across the circle to here. So it is not just y, it's not just z, it's y and z together. So we're going to have y times y plus z. Now, on the left side here, we have x times x. And x times x is x squared. So the idea on this one is, with your secant, you do the exact same thing we did with the secant-secant theorem. You take the part on the outside and multiply it by the 2 parts added together. For your tangent, you only have one piece, and what you do with that piece is you multiply it by itself or square it. So you have x squared equals y times y plus z. All right, let's do a couple examples of this. All right, here's the first one. So I'm going to start with my tangent piece, which is the 20. And so it's by itself, so what we do with it is we square it. We take 20 squared. Then we look at the secant. We start with the part on the outside, which is y, and we multiply it by both parts added together. So y plus 30. All right, and this one, we're going to get a little more algebra thrown in here, and you will see this come up sometimes. So anyways, we got 20 squared. So I'm going to square that. 20 squared is 400. Now I'm going to distribute the y. And so I got y times y is y squared. And then I have y times 30 is 30y. And so what I have here, and this is not going to happen every time you do tangent secant theorem, but it will come up occasionally whenever you end up with like an x squared and an x, or a y squared and a y. We've got two different y's here, and there's no way to combine them. We can't combine these terms because one has a squared and one doesn't. So the only way we can really work this out is through factoring. So this will be a good review of factoring. So what we want to do is get everything on one side of the equation. So I'm going to subtract the 400. When I do that, I will have 0 on the left. Everything's gone. On the right, x squared plus 30y minus 400. Now here's what we need to do. We've got to factor this into two parentheses. So we have y squared. That's going to be y times y. That's the only way we can break that down. The other thing we break down is this minus 400. And here's the idea. And here's how this goes. So think back to when you were factoring. You need two numbers that multiply to get negative 400, but that add together to get 30. So I'm thinking through, I know 400 probably has a bunch of factors, but the ones that immediately come to mind, I think of, okay, 20 times 20 is 400. But 20 and 20, if one's positive, one's negative, they're going to cancel each other out. They're not going to equal to 30. So that's not going to work. So now I go, okay, the other thing I can think of right off the top of my head is 40 and 10. 40 times 10 equals 100. Or 400, I'm sorry. 40 times 10 equals 400. If I make one positive and one negative, which I have to do because I've got a negative sign right here, I can get 30 out of that. And here's how I can do it. If I make the 10 negative and the 40 positive, 40 times negative 10 gets me negative 400. 40 plus negative 10 gets me 30. So that works. That's a solution to this. All right, so now here's the other thing you want to do with the factoring. The reason we factored this is so that we can solve for y. And when you have two factors that are equal to 0, the idea is you have two things that are being multiplied together and giving you 0. The only way that ever happens is if one of those things is 0. So what you do next is you take each factor. Take y minus 10, make it equal to 0. Take y plus 40, make it equal to 0. Now we're going to solve both of these. So I'm going to add 10 to both sides here. I get y equals 10. Over here, I have to subtract 40. I get y equals negative 40. So I have two answers, but, and this goes back to what I said on the last slide, when I'm dealing with geometry and dealing with the length or the distance of segments, I have to have positive numbers. I can't measure something in negative inches or negative centimeters. I've got to have positive numbers. So the negative 40, it fits the equation, but it doesn't work with the situation we have. It's not going to be a viable solution. So it's got to be y equals 10. And like I said, that's not going to come up a lot on these, but it will come up occasionally. So it's good that we went through one like that so you're ready for it. This next one, it also has some different types of stuff in it, but it won't be quite as complicated as the last one. Let's just go ahead and set it up. Same situation. We already have the x here by itself, and we know because it's by itself, it's the tangent line. We square it. So we have x squared. Then we take the secant. We got 9 and 16. So we're going to take 9 times both things added together, 9 plus 16. All right, x squared, don't have to do anything to that. 9 times, we're going to add together 9 and 16. 9 plus 16 is 25. And then I'm going to multiply 9 times 25, and that's 225. x squared equals 225. So we still have a squared, but this time, because we don't have like another x, we don't have to factor anything. All we need to do here is think what number squared equals 225. Or the other way you can think of this is take the square root of 225. The good news is the square root of 225 is a nice whole number. It is 15. So our answer here is x equals 15. And that's what we're looking for, is the value of x. So that's the three rules we're going to be working with. And as you are working out problems with these three rules, you will have to remember some of your algebra and use a few different techniques to solve them. So good luck with these three circle and segment rules.